Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Welcome to Homework Hotline. My name is Amy Taylor and I teach 8th grade math and Integrated 1 and Integrated 2 at Sunny Brae Middle School in Arcata.
And my name's Pam Halstead. I taught science at Fortuna High School.
Welcome to Homework Hotline. We're so excited to have you tune in, and we want to answer your science and math questions, but first we're going to show you how you can ask us questions.
Oh yes, absolutely. So if you go on homeworkhotline.tv, you Google that, and it takes you to this page, where you can then click on a link, and the link will take you to an email, the opportunity to email us your questions. And if you do that, we'll find out what the questions are.
Yeah, and then underneath that you can see watch live on YouTube. So you can either go find us on YouTube and watch, or go through that, or just watch us on Key TV channel 13. And however you're doing that, you can either use another tab to email us, or you can just email us separate and watch us on TV. So you don't have to do that all on the computer, but any of those ways is fine. But the only way we can receive your questions is if you email us. So that is the one requirement. So.
Yes, and we're ready with science and math. We'd love to answer these questions and at least try. Sometimes, yeah, it's great. We are both wearing green because this is not necessarily any time for, well, actually we talked about spring, right, on Tuesday, and things are growing and green, even though we don't have any water, which we talked about too, or as much as we normally would. And also St.
Patrick's Day is coming up, and we like to, dress accordingly, and we are on the last time before St. Patrick's Day, so we're just saying happy early St. Patrick's Day and happy spring. And
yes, very
because we'll be on after both those things happen, because March 19th we learned the first time in 124 years is the first day of spring.
That's right.
And it's usually on the 20th or 21st.
Yes,
so,
it's pretty cool.
All those things.
Very nice. We have a super exciting show today. It's very awesome. We have some super students coming on from Fortuna High School. They are both in the AP Biology class, and here they come. This is Giselle and Darlie. Yay for Giselle and Darlie, who are going to tell us, hey, welcome to the show, you guys.
Thank you for inviting us.
Absolutely. We're so happy you're here. So you're in AP Biology.
Yes.
And that's something you take after biology?
Yes.
And so if you happen to, the test I hear is pretty, you would take that test at the end of the year?
Yes.
And if you did pass that test, what would that allow you to do? It depends on what school you go to, doesn't it?
Depending on where you go to, I know UCs won't give you credit, but you could get certain college credits for the class.
Right. And it prepares you for what
yeah,
you did take
it definitely
biology
does prepare
in college,
you.
You'd be like, oh, I've seen this before. That's
yeah.
great. A very good course. Well, so you have topics that you're learning right now. Could you tell us about those?
So right now we are learning about Mendel's genetics, and it's pretty much just doing a whole bunch of Punnett squares, which you do in regular biology, but we just take it into a deeper level.
Yes, that's good. Well, I was doing that today, actually, with some students in regular biology, but yeah, the simplified version.
Yeah. And then multiplying polynomials we were talking about in math, that's kind of that same. Because I remember I would do that, I'd do like x plus 2 times x plus 3. They'd be like Punnett squares, and it's like that crossover, just to where they're at least looking at that kind of, those 4 different sections anyways.
Yes, very helpful. And math and science crossover all the time, which is really cool. All right, so you have a topic you're going to share with us today. What is that?
So we are using strawberries, and we're going to extract DNA with them.
Oh wow, that's so cool. All right, well, you want me to hold these for you
yes,
while you
please.
get ready? Okay, we'll do.
Okay.
Neat. We can move our glasses.
Oh yeah,
so
cool.
you can see.
And you have brought on a solution, and oh, look what you're doing. Cool. So you're going to filter something.
Yes.
Nice. Yes. So we have a filter. All right. So the organism that we're using. Oh, so here's a question. DNA is. Oh, here I'll just whichever of you. DNA is. Where do we find DNA basically?
Basically on everything.
Everything that's
living.
Living, exactly. So no matter. Look, we're doing strawberries, which is a wonderful thing because they smell good, huh?
Oh yeah.
And taste good.
And taste good, right?
Wonderful.
So that's better than. What's some other stuff that we've done? Spinach. I think we have someone off camera who can help me with this. You want to say it? What is the other stuff
You could
we
do
used
the
to
inside
do?
of your
The
cheek.
cheek, yeah.
Oh, that's right. Cheek is cool.
Yeah, the inside of your
Nice. All right. So what are you going to do first?
Oh, right now, well, we already had this made. This is a solution that we're going to be using, which is just water, detergent, which is like soap, and then
Salt.
and salt, and it's just mixed together. And we're going to use that.
Does it have to be a specific type of soap, like dishwashing
Not
soap?
necessarily.
Not
It
necessarily.
just attracts the cell membrane easier, so that
Yeah,
you
the
can get the
detergent
DNA
does.
out. Yeah.
Okay.
So we're gonna put the solution into the bags, and then we're gonna put the strawberries in the bags, and then mush them up. And then after that, we're gonna put them through the filter, and then filter out the juice. And then after we get that, we have some alcohol over here on the side that's being iced right now, and then we're gonna pour that in, and then should get the DNA out of them.
Cool. So here, what is it that the salt and the detergent do to the cells in the strawberry?
It attracts the DNA and it clumps it together, so you just take it out really easily.
Okay, it does something about breaking the cell membrane down,
Yeah.
maybe, or something. Like
Yes.
cell walls. Actually, this is a plant. So, okay, great. Go. Let's start.
Okay.
All right.
Thank you. Of course. You're welcome.
Oh, wow.
This is science, you everybody. Real deal.
And this is like safe science. You know, sometimes we're like, don't do this.
Yeah,
Like
at home.
soap
Right.
and salt and water seem,
Yes.
and strawberries seem reasonable for
Yes,
a home
absolutely.
experiment.
Yes, it is.
If you want to do this at home, you could.
Yeah. There's no explosions.
Don't forget to take out the air.
Oh, take out. Oh, did you hear
Yes.
that? So she said to take out the air.
Yes, take out
Don't
the
forget
air.
to take out the air.
Yes.
Why do you not want air in there? Is it harder to mush them?
Yeah.
Okay.
Oh, yeah.
And also, you don't want it coming squirting out. Yeah.
Yeah, make sure it's closed.
Nice.
Oh, you need more room because if you have all the air in there, it's harder to push down. on it.
So, you guys, why are you squishing it? What's the point of that?
Let's move these.
Breaks up the particles. It breaks them up. Breaks up
Yes.
everything.
And it releases the cells maybe in the side? Okay, awesome.
Get it smushed.
It looks just fun for kids in and of
It does.
itself.
It does. Oh my gosh. It's
Well,
turning a
we
pretty
probably
color.
want to make sure that they're not like super unripe. Like if they were green, it'd probably be hard to like mush
Yes.
them. So like
Yes.
riper probably the better, but some level of ripeness. I'm just
Yes.
thinking of that watching.
Absolutely. Oh my gosh, that'd be hard. Oh, nice.
lot
It
of
looks like
clumps.
strawberry juice.
Do you have to
It
make
does.
them all the way apart, or do you need them mostly apart?
Probably just mostly
yeah,
apart. It
most
would
of
just
them.
get the DNA out easier if they were in smaller chunks.
Okay.
Try to get them as best as we could.
Okay, sweet.
Well, you know what? If they're mushing, I could do that quick math problem.
Hey, do that. Do that. That's a great idea.
While they're mushing.
Thank you.
So we had a math problem that was sent in this morning, and it is not a lengthy one, so I can do it fairly quickly. Some of the times they're pretty lengthy, but I can do that right now. So it was 1/3 times 28, and that was the whole entire question. And then I don't even know exactly what's being asked here, but I can show you possibly what I would do. And then I would just multiply straight across to get 28/3. At that point, it depends on the answer that people want. You know, sometimes people want decimals and fractions. Now, when I teach that this is perfectly fine because there's this thing that people call improper, and I don't know why. Because 28/3 is perfectly acceptable answer, and we're not applying it to anything, and it's generic. So why do I need to change it? Take the time or think that there's something wrong with this. However, depending on the grade level, I can just change that to how many 3s go into 28. So 3 times 7 would be 21, 3 times 8, 24, 3 times 9, 27. You get 3 times 10, you get to 30. So we can't quite get to 30, and I just don't know what level this is. So I'm just telling you that. Oh yeah, I can use the eraser now. Oh, yeah. And so then what we would do is we'd go 3 times 9 is 27, so it equals 9. And 9 times 3 is 27, so we have 1 extra third. So 9 and 1/3 is also a perfectly acceptable answer. And then if we wanted to go further, if it was asking for a decimal, if you didn't know how to do that, you'd go 1 divided by 3. And then you would get that 3 goes into 10 3 times. 3 times 3 is 9. And then 3 goes into 10, again 3 times, and you would see that it repeats. So another acceptable answer would be 9.3 repeated. So those would be the 3 ways. I can't imagine that asks for another way. I guess if you wanted to round it to the nearest tenth, I guess people could also do approximately 9 3/10. So maybe 4 acceptable ways. But if they don't tell you what form, I keep it 28/3. But it's up to you what you would like to do. And I don't know what the teacher is asking, but those are all acceptable answers for that question. So good luck. I know that question was from this morning. So.
Thanks. I hope that was helpful. It was certainly helpful. All the different ways you showed us that you could do it. That's great.
Well, it depends, like the grade levels. Like sometimes, like in 3rd, they do it one way, then 4th and 5th. And it's interesting. Then when you get older, I finally say, I'm like, slope is up 28 to the right 3, and then we're using lots of that. And it's like, unless you're applying or graphing or talking about strawberries, we don't need to change it.
Nice.
All right, do we have them mushed up now?
Yes.
Okay, cool.
All right, so now we are going to put the strawberry liquid at this point through the filter. And you can use a grainer, but we're just using coffee filters, and we use 2 of them just because they break pretty easily. And then you can use your spoon or whatever you have to kind of push the liquid down.
You want to make sure you don't make a hole in it, right? The
Yeah.
filter, yeah.
Otherwise,
Too
just
much
be
will come
gentle.
through.
Oh, yeah.
Yeah. Oh, there's an idea.
try to squeeze the filter.
Just to be gentle with it. So if you just don't want to break it, so you can squeeze the filter or mix it, but you just don't want to break it to let everything
to
through.
let chunks come out,
Yeah.
yeah. Nice.
And that's just a funnel, correct?
Yeah.
Yes. We can just do 1. That's probably good.
Okay, all right.
You know, I mean, because then you'll be able to show. Okay, sweet. This is
But now we can see
this
what
is
it looks
step
like
1.
before.
Yeah,
Yeah,
that's
step
good.
1.
Okay.
There we go.
Is there a certain amount that you need, or is that adequate? Do you need like maximum amount, or?
I would say that might be enough. That's probably enough.
Okay. Nice.
Step 1.
Step 1, step 2. Cool.
So now we're going to take the iced chilled alcohol. You're going to tip it because you don't want the layers to combine.
And this is rubbing alcohol like at home, like if you get like a sore or something.
It's an antiseptic.
Yeah. So usually people have this at home. It's cheap.
Is there a reason why it's cold, darling?
Oh yeah, that's true.
It's okay, I'm just
I'm
wondering.
sure there is a reason.
I'm sure there's
but I don't know.
I just wonder.
Because usually at home you'd have it in your cupboard, so you'd have to
You would.
chill it.
Yeah, yeah. Nice, I notice it separating.
Yeah.
Yeah.
Yes.
But you want it on
Like
the
oil
top.
and water.
Yes, exactly.
So you want it above it? Is that
Yeah,
what you're
you
saying?
have it on top.
Oh, neat. Oh my
Oh,
gosh,
wow.
I see it
The
already.
DNA
What
will
is
support
that?
it.
That's
That's
DNA.
the DNA.
On the top?
Isn't that
What?
cool? Well, see all that
Yeah, this
whitey stuff?
Yeah, like you can see it. Look in the screen, like up here on the TV. You can totally see it. You can see it through the TV. I mean, you can see the little.
Oh my gosh, you so can.
It's so
Yeah,
clear.
That is
So
great.
cool.
You can see it from that angle better
Maybe
than
it
from
suspends
above.
it more if it's cold. I don't know, like instead of dissolving it. That's it. Okay, so yes, go for it.
Now we're gonna mix it.
Oh my god! Oh, it's like stick. What? What?
Isn't that crazy? It looks like mucus,
Yes.
like maybe snotty kind of mucus, which is a bad thing to think about, but
Oh, there it is.
oh, that's so cool.
Oh my gosh.
Oh my goodness. That's DNA, everybody.
Oh my
That's what your DNA looks like. That's what everybody who has DNA looks like if you prepare it this way. That is so awesome. So if you so what this tells you about a strawberry is its genes, the genes that are in it. If you were able to interpret that, so what I mean is you'd take the DNA and then you'd do something with it, right, to actually put it through. Well, actually, I was just thinking, I could be wrong, but that's a small amount of DNA, but you can make more of it, like through something called PCR. Have you guys talked about polymerase chain reaction?
No, we have not.
Okay, no problem. Just wondering if that's the case, but you would take a little bit and then you could make more copies of it. Then you could like look at what the genes are, and that's neat. So then you'd know what the genes are to make a strawberry.
Yeah.
Yeah, that is. Look, you guys can do that at home. Yeah,
That is crazy.
That's very cool.
Yeah.
It's so, and you can
simple.
see it so like vividly. It's not like you're confused, like what? I can't.
No.
I mean, it just comes right
Yeah.
out.
Yeah.
Wow. Can you test then the DNA? Is that what you?
Well, that's what I'm saying. I mean, you then would somehow isolate that DNA. I'm sure the instructor knows more than what I'm trying to say here.
But compared to other strawberries, like you could do different strawberries, like from different places of strawberries.
Yeah, you could find genes for certain characteristics of strawberries that you wanted, like more tasty or bigger or more red or more.
Okay.
Oh, the gel electrophoresis, yes. So that's right. Thanks for that. Yeah, good. So that's something you stick it into a solution, and it travels up so far based on the heaviness of the protein. Well, anyway, hey, speaking of protein, is that our next? So what does DNA do in our bodies?
DNA is what we are made up of. And then right now in class, we just finished studying how proteins are made.
Nice.
So,
do you want to do the math question first?
Oh yeah, let's do the math question
Even
first.
Though
That's
I don't
perfect.
Know that I can do that
Thank you very much.
This is going to
we'll
be
prepare
interesting.
for the next thing.
So I'm guessing this is a math counts question because that's how they ask questions like this. Like, what is the largest six-digit perfect cube? Which probably I would use a calculator to deal with this ever anyway. Like the biggest six-digit number would be that, right? And then I would probably use a calculator to cube root that and see what's close. I mean, I was just thinking if I started, like when I start math, I don't know exactly what to start with. Like if I tried like 20 cubed, then I would get 400 and then I would cube that. Not cube that. Multiply it by 20 again, and then if I did that, there's these kind of questions, these math counts questions, there's not necessarily, it's more like for fun. Not fun, but you're just trying to figure out things. But that would be 8,000, and then that's not close enough. So then maybe you would do like, maybe 200 times 200. I don't know. So that would be 4 and 4 zeros. And then if you did that, so that's 40,000 times 20, which is 8. And then 1, 2, 3, 4, 5 zeros. Are we getting closer? Kind of getting close, right? Are you following this? You guys can help me out too. I definitely sometimes make mistakes. But that's 800,000, and we're looking for what? The largest six-digit perfect cube. So 800,000 is a perfect cube. But that's the biggest. I don't know if that's the biggest. We could try 20. What?
Is that 20 or 200?
Oh, 200. 200. Thank you. See, I messed up. Which would make another one, right? Yes, thank you. Thank you. Again, I would probably just use a calculator. Why is that not erasing? I would cube root this and then see what that's close to, and then take that number, and then I would know that I was cubing to get to that number. But if I don't have a calculator, which I would tell kids to use a calculator. So that is too big, right? So that's 8 million. I don't know, it's going to be somewhere between 20 and 200. We don't probably have phones or calculators or anything like that.
Yeah, we do.
Because we could cube root this and see what we get and go from there. Because this could take, I could spend, did you cube root it?
Somebody do it? Oh, me?
So it's, no, up there. They cube rooted it, and
Oh, look,
it's 99.99. So I think it's probably 99, because 100 would be too big. Yeah, because if 100 times 100, you're going to get 1, thank you, 1, 2, 3, 4. And then that times 100 is going to be 1, 2, 3, 4, 5, 6, which is 1 million, which is basically that. So I think you would just have to go 99. So then can you on there do 99 cubed, or else I can do that on the board. So that makes sense, that 100 cubed is 1,999,000. So 100 cubed makes sense, is 1 million. Because 2, 4, 6, right? So we know that 999,999 is the biggest six-digit perfect cube. So there we go. So 99 cubed, I have just seen on this calculator, is, which I could do that obviously, but we want to learn more about strawberries. 997, what is that? 900, okay. 970,299.
Yeah.
That makes sense. So what I would do, that makes sense that 1,000,000 is right under that. We know that 100 cubed is 1,000,000, so it would make the most sense. That is just way logical, easy. Sorry about that. So 100 cubes 1,000,000. We know that's the number right under 1,000,000, so then we know it has to be 99. So 99, because 1,000,000 is 7 digits, so 99 cubed would be the answer regardless. So that would be a way around doing it also. With math count stuff, I don't teach it, and it's logic stuff, so basically. Yeah.
It's awesome to hear you talk it through because that's how things go. You have to think, okay, what am I doing? How am I doing?
But sometimes if
it's
I can't
helpful.
figure things out, and I think you have to use calculators with discretion, but I would cube root on a calculator. Then my brain would go, oh, aha, and then that triggers this stuff because sometimes my brain doesn't just come to it. So I feel like calculators are good with discretion to try things and then get your brain to come to those conclusions. So yes, the biggest 6-digit number is 970,299.
Awesome.
The biggest 6-digit perfect cube. Boom.
You have a microphone. I have a microphone. Here we go.
Okay. Poster. Yes.
Yes, poster. Okay. Sweet.
Alrighty. So, like I was saying earlier, we just finished studying protein synthesis, and that is how DNA is turned into a protein in your body. So pretty much you start off with a DNA strand, and this is it. And then it goes through transcription, which is just the copying of the DNA, and it turns into mRNA. And then that's this strand right here. So that's the pre-mRNA. And then it goes through this phase, and it has these spliceosomes that pretty much eat up the introns. They're like little Pac-Mans, kind of. So they eat these little blue ones. And then that's when the introns are removed. And then all of this is taking place inside of the nucleus. And then it goes out, and it goes into the cytoplasm. And then that's where translation takes place. And that's when you have the mRNA strand and then the ribosome. This is a ribosome, this little oval right there. And then it takes out these, what are they called? The tRNA. And then it makes them into codons. And then that turns into a polypeptide. And that's the final structure.
Nice. Of the protein.
Yes.
That is so cool. So that ASP, that GLY, those are all amino acids. They're shorthand for amino acids. Different.
Yes.
That is very neat.
So then on the strawberry, are you seeing the whole DNA, but then you're trying to, if you wanted to look into it, you would try to extract the protein to look at it more deeply? Or
No, this is what actually the function of the DNA is, to give a code to make the protein. So what about proteins? Why are proteins important in our bodies? I mean, like, can you name a protein in the body? Here, I'll help you if you, that's kind of an on-the-spot question. So your hair, your nails, and your skin are all made of, do you remember that? Or the color of your skin starts with a K. Melanin. Okay, so there's one, melanin. That gives you protection from ultraviolet light. So your hair, your skin, and your eyes are all colored with that protein. And so that, yeah. And I mean, it's so many. Like right now, there's the coronavirus, which is pretty scary. But if we had what's to the coronavirus, we wouldn't get it. And that's a protein. Do you remember? It starts with an A. Okay. They inject it with the vaccine. I'm thinking of antibodies.
Oh, right.
Okay, yeah. So if you have an antibody is another protein.
Which is why they did that for like measles, say. Once they can make those, then they give them to you, then you don't get that anymore. Well,
right. And they're working on that right now to make that
but it does
antibody.
Take time.
Or whatever the vaccine. Yeah. So it's to help you it basically makes it so that you don't have to make.
But you have to learn enough about it first to be able to
you
make
do.
And that's the problem, is if they don't know about it. They have to wait to learn about it.
Wait for forever, ever long. Yeah. Yeah, well, that is so cool because so much of our body is proteins, and we don't even work without proteins. I mean, basically, they're in our bones, our muscles, our skin, everything. So that's amazing, and it's so crazy that it can actually do that on such a tiny level.
Yeah.
Like what you showed us right there.
That was a lot of DNA.
Oh, yeah. Yeah, and think of how small that is.
Yeah, you wouldn't see like one. You need that whole clump of it to be able to see like, hey, this is DNA.
Right.
From like that. But we could see that from through the TV, which is great.
I know. So what happens if there's a mistake up here? What might happen down there?
You could get missing proteins, and that could lead to other diseases or genetic defects.
So like a mutation might happen here, and then the protein would have a problem, and you might be like, say, colorblind, or you might be an albino, which means you don't even know how to make melanin.
Yeah.
So it's amazing how important the correct sequence is. Yeah.
To protection of your body.
Well,
in a way, like that's what it's doing.
Yeah,
it's
right. To make sure that you can make correct
thriving
things.
or whatever. Yeah.
Yeah. That's very cool.
Yeah.
So much to learn and so much to know, and there's so much more that we do know than we did before. So
Oh, yeah.
that is
For
very
sure.
neat. Yay! So that's really cool that we learned about that, and this strawberry thing is fantastic.
Yes, and
Yeah.
you can do it at home. Obviously, with the alcohol, when you're younger, rubbing alcohol, like you need to chill it and work with your parents.
Right.
But the other stuff, it's like I said, like soap, salt, and water. It's,
I know.
it's
It's very
strawberry.
basic, really.
You can eat some first and then use it for
Yeah,
that.
it's so neat. Yeah, it's just hands-on science, which is awesome. And so thank you so much,
Yeah,
you guys,
thank you,
for joining our show
Yes,
and watching.
thank you.
Thank
Yay,
you so much,
Fortuna.
Darlie and Giselle and
Of
Fortuna
course.
High School and
Yay,
Sarah
bye.
Dixon, their instructor. It's really awesome.
Bye.
Thank you so much. It was great to see you. Great to be here.